Hello, this is the topic atomic structure. Atomic structure. Okay. Atomic structure. Atomic structure by Narendra Avasthi book. By Narendra Avasthi. Avasthi level 1. This one is LEVL. Level 1 questions. Okay, let us focus the question. Which of the first question? Which of the following pair is isodiapers? Okay, let us see the question. The following is which of the following pair is isodiapers? Means the pairs which have same number of same difference means same n minus p difference. Neutron minus proton difference is same. Which one of the following pair has same n minus 1 p difference? That is the question they are asking. First one, option A, they have given carbon 6, 14 and sodium 23, 11. Let us compare this one with our known topic. Okay, X means Z, A. Z means number of protons. Z means number of protons or electrons. A, number of protons or electrons. Okay. And A means this one. Okay, A is equal to mass. Okay, mass of atom. Mass of atom. A should be equal to neutron plus proton. We know from the previous concepts. Okay, here we consider 6 Z is equal to, for this one, Z is equal to 6 means number of protons are 6. Okay, 14, A is equal to 14, A is equal to 14 is equal to N plus P. Okay, we know Z is equal to 6 here, then substitute here. 6, 14, N is equal to 14 minus 6. The difference is 8. Okay, 8. So, N minus P gives rise to N is equal to 8, P is equal to 6, gives rise to 2. Then do the same with sodium atom. Here Z is equal to 11. Okay, 23 is equal to N plus P. Then 23 is equal to neutron plus 11. Protons are 11. It is Z is equal to number of protons or electrons. Okay, then N is equal to 23 minus 11. Okay, this is equal to 12. Okay, difference is equal to this one. Yes, raised to 2. N minus P is equal to N minus P. 12 minus P 11 is equal to 1. So here n minus P is equal to 2. Here n minus P is equal to 1. So these are not same. So these are known as not isodiapers. These are not diapers. Okay, these are not at all a diapers. Okay, next next concentrate another example. B, take B. Here B example contains 24 magnesium 12 and sodium. Sodium case we already saw n minus p is equal to 1. Okay, that is put here. 11. Okay, here you can calculate z is equal to 12, 24 is equal to n plus p, n plus 12. Okay, n plus 12, n is equal to 24 minus 12, which gives rise to 12. Okay, let us compare. N minus p is equal to 12 minus 12 is equal to 0. Here we already know for this atom, sodium atom, for sodium atom n minus p is equal to, we did already, here n minus p is equal to 1. Here also these two values are not same. So these are also not isodiapers. Next example, let us focus another example. C, option C. Okay, C, 4 helium 2 and oxygen 16 8. Here, okay, here Z is equal to 2, 4 is equal to n plus p. Okay, already we know p is equal to 2 protons, n plus 2, n is equal to 4 minus 2 is equal to 2. Okay, then n minus p is equal to, okay, 2 minus 2, okay, equal to 0. Okay, 2 minus 2 is equal to 0. And then z is equal to, here z is equal to 8. Okay, 16 is equal to n plus p. N plus protons are, okay, 8 we know. This is known as protons. Okay, n is equal to 16 minus 8 is equal to 8. N minus p is equal to 8 minus 8 is equal to 0. So these two values are same. So it is isodiapers. This is known by, you can, we know this one is isodiapers. Okay. In the same way, look into another problem. Which of the following does not characteristic X-rays? Okay, let us focus first one. The radiation can ionize the gas. Okay, it is correct. X-rays can ionize the gas. Next, it causes fluorescence effect on the ZNS. It is also correct. In ZNS screen, it can shows the spots or colors. So this is also correct and this is also correct. Okay, deflected by electrical and magnetic fields is incorrect. So they were asked you not a characteristic of X-rays. This is the not characteristic of X-rays. The remaining are characteristics. Have wavelength shorter than the ultraviolet radiations. Okay, have the radiation shorter than the ultraviolet radiation, because X-rays are more energetic than UV radiations. So this is also correct one. Okay, next Let us focus another question. Third question. The ratio of specific charge of proton and an alpha particle is. The ratio of specific charge of proton and an alpha particle is. Okay, the ratio of specific charge means charge by mass. Specific charge means charge by mass. Charge by mass ratio. This is also known as E by M value. Okay, E by M value for proton and alpha particle. Let us calculate E by M value for proton. Okay, proton means this one is the proton. Okay, hydrogen atom with positive charge. Okay, here E by M value for proton is equal to charge of proton is plus. Okay, that is the reason why 1 plus 1. Okay, next mass. Okay, charge here plus 1. So write it 1. Next mass here, it is the mass. So put it 1. This is 1. Next E by M value for alpha particle. Okay, E by M value for alpha particle. Is equal to, okay, alpha particle. Alpha particle means helium 4 2 plus. Okay, charge of the alpha particle is, okay, means E by M value means charge by mass. Charge of this one is 2 plus, that is means 2 by mass 4, that is equal to 1 by 2. Then the ratio, they ask you the ratio of this one by this one is E by M value of proton by E by M value of alpha particle is equal to 1 by 2. This is equal to 2:1. Okay, so 2:1 here it is the answer. Specific charge of proton and alpha particle is 2:1. So this is easy way you can calculate. Okay, next problem. Okay, increasing order for values of E by M charge by mass is. Okay, increasing order, they ask you increasing order for this type of particles. Okay, here they ask you E by M value for electron. Okay, E by M value for electron, and then calculate E by M value of proton, then calculate E by M value of neutron, and then calculate E by M value of alpha particle. Okay, we already calculate E by M value for two of them is proton, we did it, and then alpha particle we also did it. The E by M value for proton is 1, alpha particle E by M value is equal to 1 by 2. So next we have to calculate E by M value for electron and neutron. So E by M value for electron is equal to charge of electron is, electron has -1 charge. Okay, we know charge electron is indicated as E minus, charge of electron is -1, so it is called as 1. Okay, 1 charge by 1 unit charge, electron has 1 unit charge, divided by mass of electron is 0.000, okay, mass of electron is, okay, mass of electron is mass of electron is 0.000, okay, wait a minute, I will solve. Mass of electron is 0.00546, I think, nearly, I think. Okay, then you can get by doing this, you can get the value, okay, you can get the value 1837, nearly you can get 1837, I think. This is in AMU. Okay, 0.000546 AMU, atomic mass units. You can get 1837, something 800. So value is 800 region. Next, E by M value for neutron is, so simply you can represent neutron is, what is a neutron? Neutron is like this. Okay, charge of neutron is 0. We know charge of neutron is 0 divided by mass is 1. Okay, put it here. So something is like this. So which value is greater value? Okay, which value is greater value? Let us see it. Which value is greater value? Okay, increasing order for the values of E by M is, okay, charge by mass is, okay, which one has, electron has E by M value, greater E by M value, 1837 here. Next one is, okay, proton. Okay, proton E by M value is equal to 1. Next compare alpha particle is 1 by 2. Next one is neutron has 0. So this is the way you can expect E by M value increasing order. E by M value increasing order like this. Let us do another question like this. Okay. Here fifth question. Oh, answer is, okay, we forget, answer is 4 or D. D is the answer. Okay, electron, proton, alpha, neutron. Okay, this is the way you can get. Next, the mass to charge ratio of cation is this one. What is the mass of this atom? Okay, they ask you like this. What they mention is mass M by E, mass by electron is equal to 1.5 into 10 to the power of minus 8 kg. Okay, kg per coulomb. You may write like this: mass is equal to charge E into 1.5 into 10 to the power of minus 8. Kg means 10 to the power of 3 grams by coulomb. Okay. Charge of electron is 1.6 into 10 to the power of minus 19. We know from the previous classes, 10 to the power of minus 5 gram per coulomb. So then you can get the value 2.4 into 10 to the power of minus 24. It's 24. This is the way you can get minus 24. This is the C is the answer. Okay. C is the answer. 2.4 into 10 to the power of minus 24. Okay. Next one is Rutherford experiment on scattering of alpha particle showed for first time that atom has nucleus. Okay, Rutherford experiment scattering of alpha particle showed for first time that atom has nucleus. This is the way what he predicted is nucleus is present in the atom. Okay, alpha experiment for the first time that atom has nucleus. Okay, this is the fixed point. Next, alpha particle is represented by, we know here you have given alpha particle is helium 2 plus ion. Okay, alpha particle is represented by helium nuclei. Okay, helium nuclei. Eighth question, the Bohr stationary orbits electrons, first point, option A, electrons do not move. It is not correct. Electrons move emitting radiation. This is also not correct. Energy of electrons remains constant. Okay. Let us write. 8th, C. Energy of electrons remains constant. Energy of the electrons remains constant. Okay, until it cannot get the absorption. Okay, energy of electrons remains constant. Next, you can look into the matter. Angular momentum of electron is h by 2 5. It is also not correct. It is not correct because mvr is equal to nh by 2 5, not h by 2 5. This is the correct. Okay, this is not correct. Next one. Okay, on the base of Bohr model, radius of the third orbit is okay, let us calculate this one. Radius of the third orbit is, okay, we know the formula. Bohr orbit Rn is equal to 52.9 n square by z. Okay, n square by z. On the base of Bohr model, the radius of third orbit is, okay. Next, for first orbit, you can calculate first orbit, then third orbit. Then you can easily find out what is the value. For R1, okay, we can substitute 52.9 into 1 square for R1, n is equal to 1. Okay, first orbit, n is equal to 1 by z. They cannot mention any which atom it is. Okay, simply leave it the z. Next, calculate R3. For n is equal to 3, it is calculate like this: 52.9 into 3 square by z. Okay, by R1 by R3, you can calculate this one by this one. These two are cancelled each other. By 1 you can get 1 by 3 square. This is equal 1 by 9. Okay, third orbit, they mentioned third orbit is R3 is equal to cross multiplication. R3 is equal to, okay, 9 R1. Okay, 9 times radius of the first one. This is the D is the correct one. Okay, 9 times the radius of the first one. Next question, 10th question. The correct expression derived for the energy of electron in the nth energy level for hydrogen atom. The correct expression derived for the energy of an electron in nth energy level for hydrogen atom is simply given by this one. This is the fixed concept, hydrogen atom. Okay, for hydrogen atom it is the equation, which is fixed equation. Here there is another term, Z is present here, Z square is also present. Normally energy is equal to minus 2 pi square me4 Z square. Normally it has equation like this, n square h square. Here Z is equal to hydrogen atom. For hydrogen atom Z is equal to 1 hydrogen for hydrogen. So here Z is equal to 1 square, then we can get this one. So D is correct one. Next problem we do in next class. Okay, up to this one, these problems are solved. Thank you.